Cover mass percent of a solution. Okay, and the first thing that we should define is, what does that mean? Well, this means grams, because we're talking about mass. And remember, percent is part of a whole. So a mass percent of a solution is going to be grams of solute over the grams of solution. Now, remember, what is that solution made up of? It is made up of a solute, okay, the substance that is dissolved in the solvent. Okay, so the grams of solution is going to be the grams of the solute plus the grams of the solvent. And since it's a percentage, we're going to have to multiply by 100%. So far what we've looked at really is molarity. And that is moles of the solute over liters of the solution. Okay. A couple things to remember. If we have a mass, okay, we can get to moles of a substance, right? And then the second thing to remember is density. This is going to prove to be useful as well. Density is mass of a substance over volume of a substance. All right? So in this particular unit or topic, it's important to remember the definitions. Mass percent, grams of solute over grams of solution. Remember what that solution is made up of, solute and solvent. So the mass of the solution is going to be the grams of the solute plus the grams of the solvent. And it's a percent, so it's times 100. Just refreshing what molarity means: moles of solute, liters of solution. And then density being mass over volume, and what we seem to have, probably seems like we've been doing forever. If I have mass of a particular substance, I can get to moles through the molar mass. All right, so let's see what this means when we look at an example. So I have a solution made by dissolving 15.5 grams of magnesium chloride in 150 milliliters of water. We're given the density of water as being 100 grams per milliliter. What is the percent by mass of the magnesium chloride in solution? All right, so it's asking me a mass percent. Remembering that mass percent is grams of solute over grams of solution times 100%. I'm given 15.5 grams of magnesium chloride. I'm given that I have 150 milliliters of water, and that the density of water is 1 gram in 1 milliliter. Hopefully, by reading this problem, you know that this is my solute, this is my solution. I'm sorry, I didn't mean to say that. This is my solvent. Okay, so I already have this first part, grams of solute, that's the 15.5 grams of magnesium chloride. I need to get grams of the solution. Remembering that grams of solution is the grams of the solute plus the grams of the solvent. I have a volume of the solvent, and I have a density of the solvent. Oh, I can get to the mass of the solvent using these two. Once I get to the mass, I can get to the grams of the solution by adding the grams of the solute and the grams of the solvent. Okay, so let's do that. So I have 150 milliliters of H2O times in 1 milliliter, I have 1.00 grams. That's going to give me 150 grams of H2O. So my mass percent is going to be 15.5 grams of the magnesium chloride in 15.5 grams plus the 150 grams times 100. doing the math, I get 9.4% magnesium chloride solution. Okay. 2 sig figs because of the 2 sig figs on the volume given. Trying to get, oh, okay, good. Let's look at this problem. I have a 20% by mass solution of sodium hydroxide, and I'm given a density. And I'm asked, what is the molarity of this solution? Well, I know that 20%, let's assume I have 100 grams of the solution. Okay. So then I'm going to have 20 grams of sodium hydroxide per 100 grams of the solution. I'm looking for moles sodium hydroxide in a liters of solution. If I have grams of the solute, can I get to moles? Yes, molar mass. If I have the mass of the solution and the density, can I get to the volume? Yes. Okay. 40.00 grams of sodium hydroxide in 1 mole of sodium hydroxide. Then I've got 1.22 grams of solution in 1 liter of solution. I'm sorry, that's 1 milliliter times 1,000 milliliters in 1 liter. And that will get me to my moles sodium hydroxide per 1 liter solution. So 20, 100 divided by 40. I get 6.1. Okay, this 20% is really 1 sig fig, so I guess we should say it's 6 molar sodium hydroxide. All right, so that covers 2 examples and some definitions. Okay, there we go.